All right, this is Chemistry, Chapter 7, Lecture 3. You will need your lecture notes, and you'll be on page 4, and we will be at the quantum mechanical model. You'll also need a periodic table for this lecture, but no calculator for this one. All right, so in our last lecture, we talked about the Bohr model of the atom, which has a nucleus and electrons orbit it like a planet. But physicists showed in the 1920s that really isn't how it works. And they came up with the quantum mechanical model. And in the quantum mechanical model, it's a lot more complicated where the electrons reside. All right, so I'm going to teach you a very simplistic way of figuring out where is the home of all the electrons in an atom. Okay, so we call these homes orbitals. Okay, so the first is called the s orbital. Okay, that's on page 229. Sphere-shaped. Electrons can be anywhere within the sphere. Electrons move at 7/10 the speed of light, so very, very fast. And they just move anywhere within that sphere. And there's one orbital per energy level. So I'll talk to you about what an energy level is in a minute. But if we want to, this is a transparency that I used to put up in class. But this is just the figure from your book. So sphere-shaped, we can have up to 2 electrons per energy level. Each energy level, it's a bigger sphere, so the electrons get further and further out from the nucleus. Okay, and you can go many, many more than 3 energy levels. Okay, the next shape is called the p orbital, next orbital, on page 230. The book calls it a dumbbell shape. Looks a little more like a bow tie to me. P orbitals start at energy level 2. I'll show you how to figure that out on the periodic table in just a minute. And there are 3 p orbitals per energy level. X, Y, and Z axis. 1 orbital per energy level. Okay, so this is on page 230. So here's your bow tie shape or your dumbbell shape. The nucleus right in the center, and then you can have up to 2 electrons anywhere within this shape. And as you get further away from the nucleus, this would be energy level 3. The orbital gets bigger, but it's the same shape, but there can still only be 2 electrons per energy level. Excuse me, per orbital, not per energy level. 2 electrons per orbital. So this is an entire energy level, which consists of 3 dumbbell or bow tie shaped orbitals, one along the x-axis, one along the y-axis, and one up and down along the z-axis. All right, so you would get 2, 4, 6 electrons in that energy level in these dumbbell-shaped or bow tie-shaped p orbitals. All right, the next orbital is called the d orbital. They have a very complex shape, and the book doesn't even bother to put those in, but I'm going to show you a transparency in a minute. The d orbitals, there are 5 d orbitals per energy level, and you can have up to 2 electrons per orbital, so 5 times 2 is 10, okay? And then for the f orbitals, I'll show you where those are in just a second. That's another very complex shape. I'm going to show you the transparency in a minute. 7 f orbitals per energy level. Okay, so this is from a different source than your book, but I'll just show you real quickly. This is what the d orbitals look like. So you'd have 2 electrons per orbital, and you can have 5 orbitals per energy level. So 2, 4, 6, 8, 10 electrons total per energy level. All this will make sense in a minute. Just bear with me here. The f orbitals, there are 7 per energy level. 1, 2, 3, 4, 5, 6, 7. And up to 2 electrons per shape. All right, per orbital. So that'd be a total of 7 times 2 or 14. All right, let's turn the page over in your notes. And the quantum mechanical summary goes as follows. Their different shaped orbitals require increasing levels of energy in order to keep the electron in the orbital. All forms of matter seek the lowest possible or most stable energy state. That's the ground state I talked about in the last video. Each energy level is a little further away from the nucleus, and each individual orbital can hold only 2 electrons. It can also hold 1, but up to 2. So for the s orbitals, you can have 2 electrons per energy level. For the p, there are 3 orbitals per energy level, 2 for each orbital, so that'd be a total of 6. For d shapes, 10 electrons per energy level, there are 5 orbitals, 2 electrons per energy level. 2 electrons per orbital. And then for the F, you have 14 electrons per energy level. There can be up to 7 orbitals per energy level and 2 electrons for each of those orbitals. So that's 14. All right, so let me, what I'm about to teach you is what's called an electron configuration. All right, so we're going to look at neon. All right, and in your book, you've got a picture of neon. So this is the nucleus in the center, the first sphere energy level, then the next sphere energy level, and then the 3 p orbitals per energy level for a total of 10 electrons. Okay, so the way that we write out the nomenclature for where these electrons reside, I'm going to teach you a little language. If you'll turn in your book to page 235, you'll see this figure. And it just takes the periodic table. It moves, the energy levels are in this column here. It moves helium from way over here over next to hydrogen. This is called S block. All right, the electrons in S block will all be in that spherical shape, S block. This is called P block. All right, so for P block, you will have for each energy level, for all of the electrons over in here, they will be in that bow tie or dumbbell shaped p orbitals. And then this is D block here in the middle of the periodic table. So those are those 5 different shapes, 10 up to 10 electrons per energy level. Okay, so you'll have to kind of learn, because we're going to use the letters S, D, and P in our nomenclature. But you'll be using just a regular periodic table. And I took a red Sharpie, moved helium over here. That's S block, right? This is P block, all of that. This is D block. And then F block, which we won't be doing any of the atoms that have electrons in F block, but F block is all the way down here at the bottom, okay? So I'll be referring to a clean periodic table when we do the nomenclature. But the first one let's do, it's already written out in your notes, is neon. So I want to write out the system that we use to show where all the electrons in neon are. Okay, so neon is number 10. So we've got 10 electrons. So where are those 10 electrons? Well, the first 2 are in S block, in energy level 1. So hydrogen, remember helium, we bring it over here. So 1, energy level 1, shape S, 2 electrons. Okay, so we've made it through to helium. Now we bring down to energy level 2. All right, energy level 2. So 2, S, 2. Okay, where did I get that? Okay, we're in energy level 2, right here. We're in S block, which is all this. We've gone to lithium, beryllium. So we've got our first 4 electrons. Hydrogen, helium, lithium, beryllium, first 4. Then we jump all the way across here to boron, all right? Now we're in P block. And there's 1, 2, 3, 4, 5, 6 electrons when we stop at neon. So energy level 2, remember that energy level's right here. Shape P, and 6. That's the electron configuration. That tells you the energy level and the orbital for all the electrons in neon. Okay, so back to your notes. It says the sum of the superscripts. Okay, superscripts are these are up in the air, right? This is the coefficients, and then you have superscripts. There's no subscripts with this configuration. You got to write them as superscripts or I'll count off. Some of the superscripts must add up to the number of electrons in the atom. And there's one other thing I want to tell you before we go through. When you get to D block, we subtract 1 energy level. That's because electrons actually fill P block up before D block. Those complicated shapes require more energy, so it fills up P block first. So you'll see that in a minute. So look at 7.8 on page 237. I'm going to do these first two for you, and then I want you to try, pause the video, and try on your own 7.10. But we're going to do the electron configuration for phosphorus. All right, so have your periodic table handy. Phosphorus is number 15, so we've got to have superscripts that add up to 15. Our first 2 electrons are in S block, 1s2. So we've made it to helium. And then we come down here to energy level 2. We're at lithium. So that'd be 2s. The shape is S. We're in S block. And 2 electrons. 1, 2. Okay, so look at this one if you need to. 1s2, 2s2. Now we're jumping over to P block. We jump over here. We're still at energy level 2. Our shape is P. And we go 1, 2, 3, 4, 5, 6. We've made it all the way to neon. Now we're jumping down another energy level to 3. We're at sodium. We're in the S shape. And there's always at most 2 in the S shape. So 1, 2. Then we'll jump over to aluminum. All right, we're still in energy level 3. Our shape is P, and 1, 2, 3 electrons. Okay, so we've stopped here at number 15. So add up your superscripts 2, 4, 10, 12, 15. So we know where all these electrons reside, what shapes, what energy level, and how many electrons. All right, let me do another one. And hopefully you'll get the hang of it after this one. So the next one says the full electron configuration for arsenic. All right, arsenic is number 33. All right, so we're going to have superscripts that have to add up to 33. So we'll always start at the top, 1s2. And then we're at energy level 2, 2s2. And then we go over here, 2p6. Okay, 2s2, 2p6. So we've made it to neon. Then down to energy level 3, 3s2. And then we'll cross over to aluminum. We're going all the way to arsenic, so we go 1, 2, 3, 4, 5, 6, 3p6. So now we are at argon. Down here, energy level 4, 4s2. Okay, and then we're finally at D block for the first time. That's scandium, number 21. Now we subtract an energy level. So we go down to 3. 3D, we're in D block. And all the way over to zinc, that adds up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3D10. Then back up to energy level 4. Remember, you just subtract 1 for D. So energy level 4, 1, 2, 3. So gallium, germanium, arsenic. So 4p3. So if you'll, that takes you all the way, starting at hydrogen, gets you all the way 33 electrons to arsenic. Okay, if you can check yourself by adding up all those superscripts. You've got 10, 12, 18, 20, 30, 33. Now 7.10 says write the electron configuration for ruthenium. Ruthenium is number 44. So what I want you to do is pause the video and try it yourself. Okay, let's see if you got it right. So ruthenium, again, number 44. We start at energy level 1, 1s2. Then energy level 2, 2s2. Then we cross over to the p block. Energy level 2 still, 2p6. Then we go to energy level 3, 3s2, and then cross over 3p6. Okay, now we're at argon. Go to energy level 4, 4s12. We're at calcium, so 4s2. Now we're going to reduce the energy level by 1 because we've made it to D block. And we'll go all the way 10 electrons to zinc, so 3d10. Back up to energy level 4 and P here at gallium. 1, 2, 3, 4, 5, 6. We're at krypton. Let's jump down to energy level 5. 5, what block are you in here for rubidium and strontium? S block, so 5s2. And then we are back to D block, so we have to reduce the energy level by 1, 4D, 1, 2, 3, 4, 5, 6, and we stop at ruthenium. All right, hopefully you got that. If not, you can make sure you ask any questions, and when you do the homework, I'll work all the homeworks. But these are called the full electron configurations. I'm going to show you a shortcut that I think you're going to like, where you don't have to write all of that out. Okay? It's called the abbreviated electron configuration. And the way that you figure out the abbreviated electron configuration is you start by listing the closest noble gas in brackets and then go from there. All right, so let me erase this. And turn in your book one page over to page 238, and we'll do 7.11. So we want the abbreviated electron configuration for iodine. Okay, so let's look at the periodic table. We need to find iodine, and it's number 53. So man, that would be a lot of writing if we had to do the full for iodine. But you don't have to. If I say you can do abbreviated, then you can do that. Otherwise, you have to do full. You go to the previous noble gas. So the noble gases are this far right column on the periodic table. They're unreactive. And you put the previous one, which would be krypton, in brackets. So what that's saying is that iodine has krypton's electron configuration, plus, then we start from there, start from krypton. So we're at 5s2. Then we're in D block, and we have to subtract an energy level. 4d10, all the way over to cadmium. 4d10, excuse me, indium. Then we're back up to energy level 5. And we're in P block. 1, 2, 3, 4, 5. 5p5. So that saved a whole lot of writing. Now I want you to try the abbreviated electron configuration for gallium. Gallium is number 31. Number 31. So give that a try and then pause the video and then come back. All right, what is the noble gas right before gallium? It's argon. So we'll put argon in brackets. Okay, so we'll start at energy level 4, 4s2. Potassium and cadmium, energy level 4, S block, 4s2. And then 3d, we're subtracting energy level 3d10, we're at zinc. And then back to energy level 4, P. And then gallium is the very first one in P block for energy level 4, so 4p1. All right, that completes chapter 7. The homework that you can do is review questions, page 245. You can finish those up, 9 through 12. And practice problems on page 246. These are just electron configurations, 7 through 10. Please watch the linked videos for this video here, linked videos in the description box. I'm going to link several videos to help you understand this quantum mechanical model better. They won't be long. And our next video will be the solutions video for this, and then you can move on to the extra practice problems. All right, that does it for this video, and I'll talk to you on the next one.